Good afternoon, everybody. Welcome to a rainy Tuesday afternoon at Chem 11:05 with your host, me, Dr. White. Hi, everybody. Welcome back. All right. First of all, let me remind everybody that if you missed today's lecture, I'm getting there eventually. You can see yesterday I posted our first lecture on my YouTube channel. And later today, I'll work on this one, then post this one today also. So if you're ever late or if you can't make it to lecture, remember my YouTube channel for Chem 1105 has my Zoom meetings and Zoom lab. All right. First of all, I'd like to thank everybody who turned on your picture or your webcam. That makes me feel good because I can see real people. So thank you if you turn on your webcam. Also, thank you for being in my class. Now, I started last semester about halfway through doing something different, and I'm going to continue that today. On Tuesday and Thursdays, as for my syllabus, we will have labs. Now, in the past, I always waited until near the end to do the lab, which is how we do it in face-to-face. I'll have, if we were face-to-face on today, I'd have a lecture, and then we go to the lab. Well, I'm doing it differently now. I'm going to do the lab first and then the lecture. All right, now, I'm not going to hold up my box of the Carolina lab, but you should have hopefully ordered already. Hopefully you can got your Carolina lab. Now, let's first go to Blackboard. And if you click on the assignment on the side here, and let me go to student view. All right, this is what you'd see. And if you click on the left, you'll see assignments. Oh, I see a real person. Hi, real person. All right. Now, the signature sheet, please fill that out before test number 1. You have both a MS Word document and a PDF document, either one. And please upload it as a single PDF file to the assignment area here. Let's click on this for a second. Let me show you something. This is what you would see. And then you click on upload file. And then from your computer, you'd click on browse local files and you'd pick that file. And then at the lower right hand, you see submit. Now, I'm not going to submit anything because I'm the instructor. But let's look at the next thing. It's called the safety contract. And here, there are 2 things you need to fill out. One is the COD DL Lab contract. I think there's only one thing. Let me check this. Fill out this distance learning and you'll upload it as a single PDF file, or if you can write on here, and you can with MS Word, you can upload that. Be sure to sign it some way and date it. I need this. Let's go back to the right screen. There we go. I had too many windows open. And I'll need that uploaded by the end of the week. If you get it to me actually by the 15th, if you get it to me by the 15th, I will give you three bonus points. By the way, this is an example. I don't know if you've ever heard of this. There's two ways of motivating people to do things. One is the carrot and the other is the stick. And that comes back to the old days when you had a wagon and it was either being pulled by a horse or a donkey. And if you wanted it to move, the wagon, you'd either hit the horse or donkey with a whip or stick, or you could stand in front with a carrot and say, hey, would you like this carrot? Come on, follow me. And that's just reward and punishment. I don't like punishment. I'm not into that, but I am into reward. You'll see that this semester. So if you can get it to me by the 15th, the end of the day, I will give you three, yes, 1, 2, 3 bonus points. All right, let's talk about today's lab. And today's lab, I'm trying to go down and I realize I'm in student view. You don't see anymore. I do in my view when I'm in it. But anyways, you'll see number one, lab number one, safety lab. Now, all the way at the bottom, you'll see lab one, safety lab, safety spring 2023. And don't worry about spring, it's also for summer. I didn't change the name, bad Dr. White. And if we open one of those, by the way, I have the safety manual for you to look at. And when you upload the lab, I have instructions, which I talked about yesterday. If you don't have a scanner, how to use a cell phone. I used to say smartphone, but does anybody have a dumb phone? Never mind. But anyways, remember, I have a sense of humor and I use it. How to do that. And a good app for doing this that makes your life easy is called Scanner. And I have both as a Word document and a PDF how to get that. Do not buy the one version of the app where you pay money. Use the free version. Paying money isn't going to get you anything more you need. See, I saved you some money. All right, let's talk about the manual. And this is what you would see, but now I'm going to open up mine from my machine. And here it is. Now, this is the safety manual for this lab from Carolina. And it has important aspects I'm going to go over. Now, the first thing is when you're doing this lab, you should be properly dressed. And if we were face to face, I'd go over the same thing if we were in a lab. Don't wear any dangling jewelry or anything like that that can knock things over. Wear shoes that cover your feet. Don't do it barefoot or wearing sandals. This is an important thing. Your clothes should cover your body. And if you have long hair, have it tied back. As you can tell, I don't have my ponytail anymore. Well, I haven't had it for a decade. When I was in college and grad school, I had my hair down to here. Don't think about that. Oh, I see some of you are thinking about it. And I used to have it in a ponytail. And my beard was out to here. Well, it isn't anymore. But anyways, and an important thing is after doing a lab and before, you should wash your hands. You can always tell a chemist in a restroom because they wash their hands before they go to the restroom and after. I worked at one company. Oh, this is a bad story. I'll tell it. And one of the workers, it was a company that made certain hazardous chemicals that would badly irritate your skin if you got it on your skin. And this worker didn't wash his hands before he went to the restroom, and he got chemicals where you never want to get chemicals. And he had some problems for a number of months or a month or two because the irritation it caused, where you don't want to get that irritation ever. And besides that problem, for the next 5 or 6 months, everybody in the plant gave him hell for being an idiot, not washing his hands. So always wash your hands before and after you do a lab. All right, now there's certain important personal protective equipment, PPE. You've heard that term from COVID-19, but in a chemistry lab. And the most important equipment you will have, and it's in your box. Mine's a little better because they give this to us when we're face to face. These are your safety goggles, and you should wear them, even with glasses. This is the most important thing. If you're working with chemicals and that's COD, even if we're just working with water in the lab, nothing else, everybody, including the instructor, wears their safety goggles here. And you wear safety goggles. Now, I'm going to tell you a story, which is why I take safety, especially the eyes, very seriously. When I was in grad school at Michigan State, in the lab across the hall from the lab where I had my desk and did my research, there was a lab for another professor's research group. And there was a postdoctoral fellow, someone who already had his PhD, but was working in that group till he found a real job, who was working there. And we got to be friends. I don't know how, but he was a very nice guy. And his wife was a very nice person, or is. I haven't seen him in decades. You know, we went our separate ways when we left Michigan State. But one day, about right before 1 p.m., how do I know that? Because at 1 p.m., there was going to be a seminar that the organic grad students and professors were going to. And all of a sudden, there was an explosion. Boom. And I got my safety goggles on, went into that lab and helped carry this, actually help walk him outside to the shower. And he had done something, was doing an experiment, and it blew up in his face. And you're not doing anything like that with the lab kids. So relax, take a deep breath, but the story is important. And we called the paramedics, and that building, and it was wonderful. It was a brand new building too, like a year or two old. On each floor, about every 50 feet, there was a red phone, no dial. You picked it up and it was a direct line to the fire department. Michigan State was big enough, it had its own fire department. And they sent someone out and they took him to hospital, and I went there with his wife. And about 3 or 4 hours later, we were waiting. A surgeon came out, and I was sitting next to his wife and told his wife, "Your husband's very lucky. If he hadn't been wearing his safety goggles, I'd be telling you now he was blind. He's not, because he did." He did have in his whole face, because the explosion was so severe, the glass reaction vessel that he was working in, the pieces of glass that went flying into his face were so small, he had cuts all over his face. And the surgeon told us it took him about 400 stitches of 1 or 2 stitches each to sew him up. And luckily, they were such small stitches that he healed perfectly. But he had been doing something that he'd done like 45 times before, at least, making a reaction to make a chemical he needed for his research. He rushed, caused the explosion because it was a dangerous reaction, but he had done it, but he rushed. And luckily, I don't think it was luck, it was because he did have his safety goggles on, he wasn't blind. And that has stuck with me I have a photographic memory and I can still remember that right now. Like it just happened. So for the labs you do, except for two of them, one you'll be doing on paper, actually three of them, and another one you'll be working with cards, looks like a deck of cards, so you don't have to wear your safety goggles. All the others wear them. It's for your protection. Nope, that's not what I want. All right, let's go through this. And that's not what I want either. Hold on. That's what I want. Now, in the kit, you also have gloves and an apron. I would wear the apron and wear the gloves. At COD, if we were face to face, there's a rule that all people working in the lab have to wear gloves. And we provide those just like here. So please do that. All right, some important things is when you're working with the lab, don't have any food around. You shouldn't be eating, drinking, or chewing gum. Why? Because you can then get that drink or food or even your gum contaminated possibly with chemicals, and then you ingest it, which is not good. And here they talk about placing other things in your mouth while you're doing a lab, and avoid touching your face or hair or even a phone when you have your gloves on, because there are chemicals on there. You'll get those on the things like your face. In Chem 1212, we do some experiments with you all with some very hazardous chemicals. And I have to always remind students, don't do this, and because you'll get chemicals on your face. And I've had 3 times over the last number of years, students who did that. We had to put them in an eye wash and wash out part of their face. Now, always keep your area clean and organized. Know what you're going to do, and shouldn't have any unneeded papers or notebooks around. Keep cups or open wounds, hopefully you don't have any, away covered, meaning wear your gloves. I assume that's where you're going to have them on your hand, like a paper cut. And never return dispensed chemicals to the container. You just dispose of it. Most of what we'll do, and we're not doing anything with biological cultures because it's chemistry. Always wipe off. Well, this is for biology, but wipe off. Now, one thing I mentioned yesterday, and I'll mention again, and let's go somewhere. Oh, by the way, I don't get any kickback from this company, but if anybody figures how, if you look on your screen, you'll see I'm at Walmart. You can go to that French store my friend always called Target, and other places. I think Jewel has it, and others, but obviously, and buy yourself one of these large trays. They're pretty inexpensive. You can buy the 2 of them, or you don't really need it. But this one, like here, for $1.24 plus tax, and ooh, you get 2 of them too. And the reason why is a couple of chemicals. If you have a marble top in your kitchen, might damage it, might. And therefore, if you have a very expensive marble tops, and either other types of tops too, you don't want to get chemicals on there. And the safe way is to use one of these and work in those. Or you can spread out something like a plastic. I can use saran wrap. That would work too, but this works better. they say won't be damaged by bleach, but there's other things too that can be affected. You don't have to disinfect it because we're not doing or biology. We're not using a petri dish. Well, I haven't said that word in eons. All right. Now, you shouldn't really work alone in a lab. So if you're working at home, hopefully someone else is around. Like I said, clear the area of food and beverages, including drinking water. And here they say, wash your hands before and after. Read the lab thoroughly. Labs, I'm going to go through just like here. I'll go through it so you know what to do. Check always all glassware to see if you see any chips, cracks. They don't say that here, or they say cracks, or if you see a star. If you see a star in glassware, it's going to break. And I teach that face to face too. I say, well, children shouldn't be present, and you should turn off your cell phone while you're doing a lab. You shouldn't. You should never smoke, and obviously don't perform a laboratory under the influence of alcohol or drugs. If you have a spill, clean it up. Paper towels and water. If you get anything on your hand and you didn't have your gloves, shame on you. Does everybody know what this is? I've had a couple of students who are not originally from the United States that know this means shame on you. Sometimes I do shame on me too. And you should always, we're not working with scalpels. We're not doing, and clean up everything we do in your kit. If it's a liquid or dissolve it in a liquid, that can go down the drain. If you're going to pour it down the drain at the end of the lab, after you're done, I let the cold water run for a couple of minutes just to be on the safe side. And you should always clean your glassware with soap and water. And here they talk about there's an important thing, and I'm going to go through this again, called the safety data sheet, and they're available from carolina.com. And that tells you the various hazards and everything. And if it's flammable, you'll see this symbol, corrosive, this symbol. And they have other symbols you can read at your leisure. And here they got, why do we wear goggles? You can watch this, but I hope my story, which I told you, which was not a pleasant thing, especially for my friend to experience, wear your goggles. Same thing with gloves. We're not doing any field work, and therefore you don't have to fill that out. All right. I highly recommend you go back and review this. Now, let's look at, let me close this. Here's the DL. I can close that. Don't need that. All the fun of working with Zoom. All right. This is the safety lab. Did I just delete? Hold on. There we go. This is a safety lab that you can download as a PDF file or as a Word document. And if you notice, this is a sign we have in each lab at COD, what you should be wearing during a lab, especially the safety goggles. Those are, and safety glasses are not, will not protect your eyes because you can have splashes coming inside. Goggles will totally protect. And here's some videos I'll let you watch at your own leisure. Now, notice some of them are in red. Those are the ones you should look at. Now, here we have the different labels that you can find on the SDS. I also use the old term, which is MSDS. SDS is Safety Data Sheet. MSDS is Material Safety Data Sheet. And I went through these already. By the way, we're not doing anything that will explode, or gas cylinder, or oxidizers. All right, now, here on an MSDS, or they use that, or SDS, they're essentially the same. We have the National Fire Protection Association diamond, and notice they have the numbers. When the higher the number, the worse the hazard. A 2 in there is red, and that's a fire hazard. If it was 0, it would be a not bad fire hazard. And here they use the newer GHS, which again tells you things about the safety. Here's some more videos to watch. Now, in this lab, I'm going to ask you to answer these questions. And by Thursday, remember, every lab is due the next week. This you can download as the file that caused either as a PDF or MS Word doc, Lab 1, Safety Spring 2023. And they have various questions. And one thing I haven't mentioned, if you ever get chemicals on your hand, you'll put it under the water, under your arm or wherever, underwater for about 10, 15 minutes. You don't want to use soap because certain chemicals soap will react with and it'll make it worse. Now, let's go to the internet. Now, let's see, if are you seeing what I'm seeing? You are. I went to my favorite search engine, Google. I've been using Google since about a week or two after it came online. A friend of mine in California called me and said, you should check this out. And I was back in the mid 90s, companies didn't let people have internet access unless you were a senior manager because they figured workers would goof off on the internet. Well, I always had it. So I looked and I saw this Google and an empty box. All right, what do I do next? And he said, type this in and hit enter. I said, whoa, is that wicked? But anyways, I put in sodium hydroxide, MSDS, and let's hit enter. And you'll notice I have a number of companies. Sigma Aldrich and Fisher Scientific are very reputable chemical companies. And if we click on the one from Aldrich, or no, Fisher, here's the safety data sheet, also known as MSDS. And for chemicals that I invented, I had to help them write these. But anyways, here they always have similar things. Here they have the name and then hazards. You can see here, serious eye damage, category 1, and so on. And certain precautions. And here again, more information. And here they give you the two different scales, which tells you, and you can look up what is blue, what is red, is fire, and so on. And this one is a solution. I didn't get to solid. And they have first aid measures and firefighting measures. And if you accidentally, if you were in a chemical plant, release it to the ground, and also how to handle it. And here, personal protection. And they have other things here, physical properties and stability, reactivity, and toxicological information. And we'll talk more about this when I talk about things, materials. So the MSDS or SDS has a lot of information that's very important for you to know when you're handling certain chemicals. And how do you find it? Well, the easiest way now online is go online for the stuff in your kit. You can go online through Google, or you can go to carolina.com and find them. Like I said, here's some questions, and if you've been paying attention, you should know how to answer these questions. Now, let me talk about question 7, because students interpret this wrong. Here it says, what is the NFPA health rating? Not all of them, just the health rating for sodium hydroxide. I just showed you how to get that one. Sodium bicarbonate and copper sulfate. And number 8, and this is important, listen, what chemical is the most hazardous chemical in question 7? And that's only based on the health rating, not the others. That's all I want you to base what is the most and what is the reason that it is the most hazardous chemical. So you have sodium hydroxide, sodium carbonate, and
Excuse me,
copper sulfate.
Professor.
Yes,
Sorry, I have a question. So for question 7, we would find it under where you just showed us.
right. You are going to have to look up the SDS.
Okay.
Go to Google for sodium hydroxide. You see how I put in?
Yeah, so we would just look them up for each individual term.
Right. Well, you'd have to, for each chemical A, B, and C, you would go to the MSDS, scroll down, find the NFPF health rating.
Okay.
The higher the number, the more dangerous it is.
Okay, thank you.
And as you see, as I mentioned yesterday, and I should have mentioned it already today, in my class, in my world, there's no such thing as a dumb question. And thank you for your question. Oh, by the way, I have found over the years, if one student has a question, usually a lot others in the class has a similar or same question. So you've helped everybody out besides yourself. Thank you. And this, what you will do for by Thursday, end of the day, you will upload these answers. Now, if you don't have a printer, just put down your name, question 1 and your answer, question 2 and your answer, and so on. And then you use your cell phone, or if you don't have a scanner, and upload as a single PDF file. And that's today's lab. I hope you enjoyed it. Safety is very important whenever you're dealing with chemicals. I've worked in chemical plants where you have to be very careful. Luckily, the companies I work for, there was no, oh, another live person, hi, live person. But anyways, been very careful. Chemical plants, and by the way, don't tell anybody, but in the end of the semester, I have a really big surprise for you. Shh, don't tell anybody.
I have a question.
Yes, Stuart.
For this lab, do we have to take a picture of ourselves or no? Because
It's the only one you don't. That's a good point. I'll mention that the other labs. For, if you want to send me a picture, you can. This one, you don't have to. This is the only one you don't, there's two others we do, I think, where
Oh.
you don't have to. One is a balanced chemical equations. I think there's just one other than this one. So it's total of two.
all right.
You don't have to. Okay?
And since it's like we just like fill it out, can we just
Yeah,
answer
short answers.
Yeah, so
You
can
can-
we like fill it out on what you sent us and then save as the PDF and send it to you?
You can do that and type it in. You can handwrite it. You can print it. If you handwrite it or print it, make sure you do it clearly so I can read it, because you don't want me guessing at what the heck is that answer. So I can
Oh.
guess right or wrong. Okay?
And is it due this Thursday or next Thursday?
No, this Thursday.
Okay.
Labs are always due the next lab period. Our labs are due Tuesday and Thursday. Let's do
Okay.
something. Let me get. I already closed it. Hang in there. I always say that, hang in there. Don't let go. All right, I'm in student view. Can you see that on your screen? If you click on assignments, and let's go to safety lab. Let me move the videos out of pictures out of the way. You see on the right-hand part of your screen where it says due date? And guess what? I got it right. It's by 8 o'clock this Thursday. If it's late, I take off points. So it's in your best interest to get it in on time. Okay? And you'll see every lab you'll do, the due date will be on this part of the screen. And by the way, if you're not sure or unsure of it, you can always email me. But each one of these labs, there's the due date. And it's 10 points. So make sure you get it in so you get 10. Yes, 5 and 5, that's 10 points. It's easy points. All right. Any other questions about today's lab? I see someone. And the answer is yes. I'll have to make sure you have both of those. One's for COD and the other is the distance learning. Let me check on that. I'll get back to you on an email. They started a distance learning contract last semester, and I think I did both of them, but maybe we don't have to. I'll check with the lab manager on that. All right, any other questions on today's lab? All right, let me close something. All right, let's get back to chemistry lecture. And yesterday, I ended up talking about mixtures. And mixtures are two substances that are physically combined, but not chemically. In other words, you mix them together, and each one still has its own chemical identity. And how can you tell that? Where if I were to take, let's pick on salt today, sodium chloride, and water, H2O. And for those of you who know German, H2O is Wasser. And for Hispanic or Latin American or Spanish is aqua, I believe. See, I'm multilingual sometimes. And if you're mixed together, you can dissolve them. And I'll teach you later in the semester when we talk about something called solutions. And you can heat up, and we actually do this at face-to-face lab. You don't do it in your lab with the chem kit. You have a solution or mixture of water and salt. You can heat it up and evaporate the water and get back the salt. Actually, that's how they make sea salt. They take seawater and evaporate off the water. So this is a mixture. And we talked about other mixtures, our example, the air you're breathing. That's a mixture of nitrogen and oxygen. Gasoline is a very complex mixture. And pop you drink, soda. Well, I don't call it soda, I call it pop. That's what we call it in the Chicagoland area. And also your tea and coffee are mixtures. So there's a lot of mixtures in your life. Now, time for a public service announcement from Dr. White, me. Now, when I worked at one company, CHEMI, which is an international chemical company, at that time, I started out as a bench chemist, and within a year and a half, I was the youngest section head in that company worldwide. And I was in charge of all research, product, process, and product development research for all of North America. And one of the things that company made was chemicals that were used as additives in gasoline. And I was one of the one of the only two R&D chemists, PhD chemists, that marketing and sales took out the customers because they knew I was going to help them make sales. So I got to go to all the petroleum companies throughout the United States back then, and I would talk to the various research chemists there. And because I had a PhD, this guy's always honest, which I was, but I had more credibility than the salesman ever did, which is why they like to take me along. And because of that, I got to learn a lot about gasoline from companies like Shell, BP, Mobil, went to all their research headquarters. And now I'm going to share you something. This is my opinion. Take it for what it's worth. You're not having to pay for it. We have to pay to get in my class, but this is separate. All right, the best gasoline is Shell. It has been for decades. It's the best. The next best, right below it, and almost as good, is Mobil. And the very worst is BP, used to be called Standard. If you remember, and probably you don't, but I remember because I have worked in that industry or with people in that industry, about 5-7 years ago, here in the Chicagoland area, around Gary, Indiana, both in the Indiana side and the Illinois side of the border, BP made gasoline that was so bad, it destroyed the car engines of about 4,000 cars. Yep, that's bad. And I will not, unless it's the ultra only gas I can get emergency, which in Chicagoland it never is. I will never put BP in my car, period. Never have. Since I learned about gasoline back when I was young, there was a then called Standard station near our house we used, but now I would never go there to BP. Now, another public service I should do for you. All right, you should see on your screen right now a site called Gas Buddy. Now, their URL is chicagogasprices.com. And I've been using this site for years. You put in a zip code, hit enter, and I put in the zip code for by Glen Ellen. And you can see the different gas stations. By the way, right by COD, there's that Shell, and down the road, there's a BP, the bottom one. If you look at this, you go about 3 miles, one's 419, one's 449. And you'll find that throughout the area, whatever zip code, you can go a couple miles and there's a great difference in the price. And I do this for where I live and when I used to go face to face at COD, and also the other school I teach at when I teach on Zoom this semester, but that's in Elgin. And I go to this Shell on McLean and Fleetwood I've gone to, and right across the street is a Marathon. Marathon's a very good gas too. But BP, no. And that's my public service for you. You can save a lot of money. It's amazing how I live in Schaumburg and it's in Cook County, and we have a 10 cent a gallon tax on gasoline. But sometimes the gasoline where I live, say at a Shell or Mobil, is cheaper than or less expensive than the gas in, say, Glen Ellen, or which is DuPage County, or in Elgin, which is Kane County. Makes no sense why that should be more expensive than Cook, but it is.
Professor, do you think it makes a difference in, like, you know how they have like 3 kinds of
All
gasoline?
right, that's a good question.
So I've been
Yeah.
putting BP on my car for 4 years because I thought that was like the best.
Isn't, well, if your car's running okay, it's okay. Now, you brought up something I would have forgotten to mention. Now, the 3 different grades are octane numbers, but they also have different additives. Additives help make your car run better. Now, unless you're driving a Ferrari or a Lamborghini, which unfortunately I haven't bought one yet. But anyways, if you are, then I would always use the highest octane. Now, what I do, and I've done this for a number of new cars I've had, and I keep them for a while. And I've had both Oldsmobiles, and now the last couple of cars, I've had Ford Explorers. Most of the time, 90% of the time, I use the lowest octane, the least expensive gas. I usually only use Shell or Mobil. I don't have any Marathon near my house. When I used to go to ECC in Elgin, there was a Marathon there that I would sometimes use till they built a Shell station right across, and Shell is the best, so I do use them. Now, what I will do is about 4 times a year, I will this is my own preference. I normally don't let my gas go below half a tank. This is something my father did, and I think it's good advice. I do. But I'll let the gas go down to a quarter. I never get it down to empty or near there. No, I don't want to run out of gas. That's my own personal preference. And about 4 times a year, when it's down to a quarter, I'll fill the tank up with the highest octane, best, most expensive gasoline they sell. And that has certain additives. And actually, I worked for the company, like I said, that sold some of the additives to those companies. And I learned that's the big difference, is the additives. And by doing that a couple times a year, that helps clean out some of the gunk in my car engines. And I better not say this, but I don't have problems with car engines because I do that. Now, the other time I also do it is, you know how when you have to every once in a while go in and get your air quality test for your car at the Illinois station that tests it? What I will do is, the day I'm going to have that done, a couple of days before, I've let my gas go down to a quarter, and I'll fill it up with the highest octane, most expensive gas. And then right before the test, since I don't live far from there, I'll get on 355, go about 10 minutes, then turn around, come back 10 minutes, and then go right to the testing center. And that way my engine is nice and warm. Any kind of garbage that was in there by going on the highway, I've blown it out of there. By the way, I have a radar detector and I don't go the speed limit. I'm one of those people in the third lane, but not driving too crazy. There's some crazies out there. And that's that. Does that help?
Yeah, so just basically use regular and do the expensive one 4 times a year.
Yeah, just a couple of times, unless you have a Lamborghini, Ferrari, or Porsche with a big engine in it. Or if you have an old car that has a monster engine, I learned how to drive my mother's car. My father had a Volkswagen, which is all right. I wasn't a Volkswagen fan. He was. But my mother liked speed, and I learned on a Impala Super Sport with a 427 engine in it. It was one of the fastest cars on the road. All right. Well, if I look at the clock, let's take a 5-minute break. I can get up and stretch, and we'll come back and do some chemistry. So I'll see you in 5. Time to start again. Welcome back. Well, back when I was in high school, I collected whistles. Don't ask me why. Unfortunately, I lost my police whistle, but I still have my train whistle too. Let's get rolling. All right, welcome back, everybody. Let's get back to work. Now, I was talking about mixtures, and as you know, from what I mentioned earlier, my public service announcement, throughout the semester, at certain times, I'll teach you things about things I know from having worked in the chemical industry that help you. All right, now there are two types of mixtures. And I'm going to be subtle. Everybody get the hint? Know this. All right. The two types of mixtures are homogeneous mixture and heterogeneous mixture. Now, homogeneous mixture is uniform throughout the sample. And later in the semester, I'll teach you that's called a solution. That means it's the same throughout. If I had a bottle of a mixture, if I sample it here, here, or here, it's the same mixture. And that's called homogeneous, homo meaning the same. And an example of that would be, well, hopefully yours is, oops, wrong color. I keep red for special things. Your gasoline is a homogeneous mixture. If you take salt and water, or if you take sugar and water, they're all going to be, once you mix it up, the same throughout. Obviously, the sugar water is going to taste better than the salt water, unless you're a salt freak, which I'm not. All right, now that's a homogeneous mixture. By the way, your air, your breathing now is homogeneous. If you go to another part of the room you're in, you're not going to go, oh no, no oxygen. I can't breathe right. No, it's the same mixture throughout. It's homogeneous. So next time we're with some friends at a party, you can say, you know, the air you're breathing is homogeneous mixture. Don't. Friends don't like to hear chemistry at a party. All right. Now, the other type you should know is a heterogeneous mixture. Heterogeneous, it's not uniform throughout. Now, one example would be if I took sand and mixed it with water. And I won't do it with my water bottle, but if I were to take sand and put some sand in here, shake it up, the sand would all go to the bottom because sand's not soluble in water. And up here would be the water. And that would be a heterogeneous mixture. By the way, Trump has pleaded not guilty. All right, what a mess we're living in right now. Now, this was my mother's favorite wishbone salad dressing. Everybody see that picture on the screen here? If you look at this bottle where it says Italian, you'll see there's two layers there. The lower layer, by the way, Italian dressing is an oil vinaigrette dressing. Oil meaning vegetable oil, vinaigrette. Vinegar is a mixture of water, mainly water, and something called acetic acid. And if you notice how it separates, if you shake it up, it stays a while and you put it on your salad. And then if you put the bottle down, they separate. When you see two separate layers like that, that tells you that's a heterogeneous mixture. And you should know examples of homogeneous and heterogeneous mixtures. By the way, I've learned since then, but I don't know if I mentioned this. If you're a good organic chemist, you're a good cook. If somebody says they're a good organic chemist and they're not a good cook, they're lying to you. Because every good organic chemist, including myself, are good cooks. I was lucky because my generation, even my father's generation, men didn't cook, but my father loved to cook, and I would cook with him because some Sundays he'd say, all right, men only. I have two sisters and my mother, and they were excluded from the kitchen. So we could spend some quality time cooking together. That was fun. Anyways, I've since learned you can make your own a lot better than this. If you take some garlic, some vinegar, and the best vinegar I found is the Japanese Marucan rice wine vinegar, and vegetable oil. You can make your own Italian dressing, a little salt and pepper too. But next time you're in a supermarket and you happen to see the wishbone and other Italian where it's two layers, you can think, aha, that's a heterogeneous mixture. If you walk down the aisle with Pop, and I better teach you something good. Such as Dr. Pepper. Yes, I'm a pepper. I like Dr. Pepper. And if you look at the bottle, it's the same throughout, and that's a homogeneous solution. But you didn't think about chemistry when you were in the supermarket. All right, so you should know examples of what is a homogeneous solution. That means it's the same throughout. And what's a heterogeneous mixture? And on tests, I get asked 2 or 3 points. Give an example of a heterogeneous mixture. You could put down sand and water. You could put down oil vinaigrette or wishbone Italian salad dressing. A homogeneous mixture would be gasoline, pop, air, salt water, sugar water solutions. Now, let's talk about matter. And remember, chemistry investigates the study of different aspects of matter. And matter is something that has mass and occupies space. Now, properties of matter, and I'll never ask you what are properties of matter, are characteristics that distinguish one substance from another. Now, one type of property are physical properties, and those are characteristics of a substance that can be observed without changing the basic identity of the substance. In other words, there are distinguishing characteristics of a substance that are used in its identification and description. Now, what would be an example of a physical property? Oh, I better be subtle again. Example would be if we were at COD, I'd say, look outside the window in the parking lot, and you can see cars that are different colors. And I could ask you, how many cars are yellow, red, blue, green, whatever, and you could find out. Now, that would be a physical property. Another physical property, if you look at my ring here, it's gold. Yeah, these are back in the day when they made these rings of solid gold for 14 karat, and it's shiny. You can shine it up. This needs to be shined up. And luster, meaning it can be shined up, is a property of gold. If you had a piece of carbon coal, no matter how hard you rubbed it, it's not going to have luster sharp. It's not going to be shined up. Now, another example of a physical property are the boiling point and melting point of a substance. Now, boiling point is the temperature at which that substance boils. Goes from a liquid to gas, and we'll talk more about that this semester. And melting point is when a substance goes from a liquid to a solid, or actually melting point is solid to a liquid. And in water boils in the Chicagoland area, and I'll teach you more about this later in the semester, at 100 degrees Celsius, C. And it melts at 0 degrees or 32 degrees F. Now, let me show you something important that you should know. This is Wikipedia. When it first came out, I used to call it the wrong way of pronouncing it. My students would yell, no, it's Wikipedia. I used to call it Wikipedia. No, it's Wikipedia. Now, Wikipedia is for chemistry, 99.9% always correct. Over the years, I have the credentials and other chemists have policed Wikipedia and have changes made. Yes, I have the credentials. When I ask for a change in an entry in Wikipedia, they get made. And therefore, I don't know about other stuff, but chemistry, it's 99% spot on. Now, if you scroll down for chemicals, like water, yes, it's a chemical, you'll see they always have properties. And here they have the melting point, 0.0 degrees C, 32 degrees F, and the boiling point, now they have 99.98, it's really 100. But anyways, I'll leave it alone for now. I won't call them and say, email them, change that to 100. But anyways, if you're any chemicals, well, let's do another one while we're here. Sodium chloride is table salt, also known as salt. If we scroll down, you'll see properties. Now, the melting point of salt is really high, 800.7 degrees C or 1,473.3 degrees Fahrenheit. And it boils at a high temperature too. I have never melted or boiled salt. I don't have anything that goes that high. My oven only goes up to 500 degrees F, not almost 1,500 degrees F. Boy, that burned down my house. So whenever you look up a chemical in Wikipedia, the information they give you is generally spot on, can be believed. Other things I don't know about, but I know chemistry. And I do know chemistry. All right, so those are physical properties. There's also something called chemical properties, and that is a characteristic that describes the ability of a substance to change into a new substance. I will never ask on a test, what's the definition of a chemical property? But I will ask you to give me examples. Now, examples of chemical properties, and this illustrates the ability of a substance to change into a new substance, is iron in car can rust. Regular steel can rust. That's why they put the paint job called a coating on your car to stop that. Now, if you're old enough to remember the DeLorean, which was made of stainless steel, and stainless steel does not rust. By the way, that's the car in Back to the Future, all three movies that it was in. Now, another example of a physical property is flammability. Do not try this at home, and I'm not going to try it, but here's a piece of paper. And if I put a match under it, do not try this at home ever, it will burn. Paper is flammable. If I take water and put a match under it, or like this, guess what? It won't burn. Water is used by our firemen to put out fires. And that's a different chemical property. Water, not flammable. Gasoline, and do not try that at home, is flammable like this. And they're different chemical properties. Another one, which do not try, certain substances are toxic. If you were to consume it, it would kill you. Other things, if you consume not too much, water will not kill you, even though if you drown in it, that will, but if you drink a normal amount, oh, I'm thirsty, I think I have some. Oh, that's good. But anyways, that's chemical properties. And throughout the semester, we'll talk about chemical properties. Chemical properties. We'll talk about how chemical property, no, it's not a chemical, it's a physical. But anyways, I'll talk about different chemical and physical properties. And you should know, oh, I forgot to write it down. Hold on. You should know examples of chemical properties. And I think I forgot to write it down here. Nope, I did there. Examples of physical properties. Now, when we talk about matter, you can have changes in matter. And there are two types of changes, just like chemical and physical properties. There's a physical change and a chemical change. Now, physical change is a process in which a substance changes its physical appearance, but not its chemical composition. An example I don't always write this down, but for now, I'm helping you out. What's an example of a physical change? When water is ice, a solid, and it melts to a liquid, it's still water, but it's in a different physical state of matter. Example would be if you took water that's a liquid and boil it, the gas, and I'll teach you more about boiling liquids, the gas above the boiling water is water in a gas form, and that's a physical change. And those are physical changes you see. Now, chemical change is when an original substance is converted into a new substance that has different composition, new chemicals, new chemical and physical properties. Examples of that, be careful, when you have a lighter, you know, those little lighters that have the liquid in them, when you click it and do a spark, it causes the butane to burn to give off carbon dioxide and water plus the heat, the flame. That's a chemical change. Now, not to scare you, but when you digest food, by the way, when I was about 2 or 3, my mother said, you better chew your food before you swallow it or you'll choke. Guess what? She wasn't lying to me. I did choke one time. I learned my lesson the hard way when I was young sometimes. Good news, I'm still alive. I survived. I learned to chew it. when you chew it and swallow it, it goes in your stomach is doing chemical changes. Yes, you're a walking chemical plant. You didn't know that. See, chemistry is everywhere. And digesting food is chemistry. Another one, I think I'm going for the Guinness Book of World Record of writing hint, know this the most in one day, which helps you out, and that's a good thing. You should know examples of chemical and physical changes. And another one would be if you're in a car running on gasoline and the car engine is burning the gasoline, that's called combustion, to make energy plus carbon dioxide and water, and that's a chemical change. The gasoline reacting with the air in your car engine is undergoing a chemical change. All right, every book usually throws it in here. Let's talk about temperature. Now, I'll never ask you what is temperature, but it's a measure of how hot or cold the substance is compared to another substance. Another way of saying that is heat flows from a substance of higher temperature to a substance of lower temperature. So that's temperature. And it's an important part of our life. Now, when it comes to temperature, there are three scales chemists use in measuring temperature of a substance. First one is Celsius. Which is abbreviated by degrees C. Now, sometimes that I've caught myself until I was, I think in grad school or even college, it was called centigrade and they changed it to Celsius. Another one is Kelvin. And Kelvin is used mainly for gases at very high or very low temperatures. I mean, really low, like in outer space. And it's not a degree, it's an absolute scale. So that's why it's named after Lord Kelvin, an important chemist, English chemist. I forgot what his original name was before he was made a lord by the Queen of England back then. That's the first Queen Elizabeth, not the second. I think that was who did. And the last one, which you're familiar with, being in the United States, is Fahrenheit, degrees F. So there are three temperature scales, Celsius, Kelvin, and Fahrenheit. Now, in the United States, most of us measure temperature by Fahrenheit. In Europe and the rest of the world, it's Celsius. England, they do Fahrenheit. Now, there are formulas that allow you to switch from one scale to another, convert from one scale to other. Now, in the past, you would have to memorize these formulas. Good news, as I said, I have cut down way down on memorization. I will give these to you on the test on the last page, important information whenever you need to do those. Now, let's look at the formula. Let's look at the first one right here. And that's how do you convert from Celsius, I almost said centigrade, the old name, to Fahrenheit? You use this formula. You multiply the degrees C times 1.8 and you add 32. And let's take a look how you use that. Say sometime in the future, you see something on a piece of paper or on a screen you printed out, 4 points. And if you were face to face, you'd be watching me write this on a whiteboard. All right, now everybody take a deep breath. Let it out. Take another deep breath. Let it out. This is a word problem. Relax. Now watch closely. This is something I teach students and I've been doing when I was an undergrad. I don't know where I've been, even in high school, I picked it up. First thing I'm going to do is I'm going to read it. Then I'm going to be asked, what am I being asked to find? And that's degrees F. And I'll write a question mark, and don't ask me how I came up with that, degrees F. Everybody get what I just did? I figured out, what am I being asked to find? This right here. What am I given? The temperature is 12.6 degrees C. Now I don't have to read this ever again, because this gives me all the information I need to do the problem. And what do? We use the formula, which you will be given, but you have to know when to use it. This. And now I know my degree C is this, so I can put this in. Now, one of the things I've learned as an undergrad and grad student, by the way, in my undergrad and grad school, I took way more tests than you ever have. I found I get better scores on tests when I let the paper do the thinking. Wait a second, paper, think? And the answer is yes. Don't take shorthand, write things out like this. It may take a few seconds more, but it makes a difference in how well you do on a test. Also, I give partial credit if I see you make a math error. But if you were to write this down like this, and then come up with the wrong answer, well, I'd say, oh, you made a math error, and I'll give you 3 out of 4 points. If you just write down the answer and it's wrong without showing your work, you get 0 points. So it always pays to show the work. Now, I won't do it today, but tomorrow in Collapser, I'll teach you how to use a calculator, because we'll need it for other things. But for now, let me turn it on, clear it. On this formula, you do the multiplication first. Hold on, I made a mistake. My calculator, and I'll teach you later about something called significant figures. And this is the answer you get. Now, and after I teach you significant figures, you'll learn how to round that off to the correct answer. But for now, I haven't taught that. So what did I do? I read the problem. I found out, what am I being asked to find? And I write it down with a question mark. Now, you don't have to do this, but it works real well. Then I look at, what am I given? And once I have that, I don't have to read the problem again. And I know to use this formula. I put it in degrees C and do the math. You know something? I've been very mean to you. I haven't been sharing the fun. So I'm going to share the fun. Let's do another one. All right, let's do this stepwise. Read the problem and write down right here, what are you being asked to find and what are you given? Your turn. Just let's do it stepwise. I just realized I haven't set up polling yet for this class, for these Zoom meetings. I'll do that later today.
I got 47.48, but I don't know if it's right.
But for this one,
Yeah.
I haven't done that yet. You're ahead of me. Good. Don't you feel good about yourself? You can do this. All right, let's find out. What are you being asked to find? Degrees F. What are you given? 8.6 degrees C. Now, there's a formula you use. Degrees F equals 1.8 times degrees C plus 32. And now I'll put in, because I figured out degrees C is 8.6. And now I'll pick up my trusty calculator. And I got 47 point, and I see I've been ignoring the chat, and I apologize. Let me look at the chat. Oh, wow, someone else agreed with me. All right. And that's how you do it. Is everybody clear on that? You use this formula to convert from degrees C to degrees F. And someone asked about the contracts. I'm going to check if it's one or two. I mean, I forgot last semester was the first time we did the distance learning, because last semester was the first time we used the Carolina labs. All right, let's look at the second formula. That goes from degrees F to degrees C. You take degrees F and you subtract 32, and then you divide by 1.8. Listen carefully, because I don't want you to make this mistake on a test. Students make the mistake of dividing degrees F by 1.8 and 32 by 1.8 and then subtract. No, that's wrong. You do what's in the bracket first, and then you divide by 1.8. All right, so let's take a look at this. By the way, PTS is abbreviation for points. A few days later, I'll be finished. All right, the outside temperature is 68.5 degrees F Fahrenheit. What is the temperature in degrees C Celsius? So what are we being asked to find? Degrees C. What are we given? That. And important information, degrees C equals degrees F minus 32 divided by 1.8. And what's degrees F? Well, we took the time to figure that out. 68.5 degrees F minus 32 divided by 1.8. Hold on while I check the chat again. Somebody's ahead of me already. Gotta wait until I do it too. No, you don't have to. Clear my calculator. Remember, do the subtraction first. And my calculator, I'm not going to write the whole thing out. And a lot more sevens after that. And that's how you do it. Now, I forgot to tell you a story. For many years, I worked for two separate companies, and they were actually Anglo-Dutch, mainly Dutch companies. So I would go to Europe a lot. And this was in the 80s and 90s. And after that, I worked for an American company, which I didn't go to Europe a lot. But when I mean a lot, anywhere from 3 to 6 times a year. When I go to Europe, I'd be there for anywhere from 2 to 4 weeks. And the Dutch companies, I always would end up my trip. I could manage it. Friday, I get to Amsterdam and fly out Sunday morning. If you've never been to Amsterdam, boy, you're missing a lot. Also, Guadalajara is a good city to go to too. But whenever I listen to the weather, what should I wear before I leave my hotel room? It would always be in degrees C. And my mind works with clothing in degrees F. So I'd always have to do this formula. Oh, I should wear a sweater or a coat, or I don't need anything. All right, let's try one more of these. And I'm going to let you try this all on your own. Hold on. All right, there you go. If the temperature of an oven is 355 degrees F, then what is the temperature in degrees C? Your turn. And when you're done, give me a thumbs up emoji if you can, please. Thank you. I see one person. And by the way, I try and give everybody time to finish. So if you're finished early, please be patient. I see some more people finishing. Tomorrow I'll have where you do a poll. All right, let me do it now. So if the temperature of oven is 355 degrees F, then what is the temperature in degrees C? So what are we being asked to find? Degrees C. What are we given? And from important information, test number 1, you'll know degrees C equals degrees F minus 32 divided by 1.8. We took the time to figure out what degrees F is. Put it in the formula. Remember, do the subtraction first. That's a mistake students make. They divide each one of those by 1.8 and then do the subtraction. Wrong. And you get and a lot more fours after that, and I'll teach you later on how to do that. And that's how you go from degrees F to degrees C. Now, the final one is Kelvin. And Kelvin equals degrees C plus 273. Always want to put a degree sign. There isn't one for Kelvin. I see someone has a question, so let me check it. Oh, somebody beat me to it already. Thank you, Julia. All right, so let's take a look at this. What are we trying to find? The temperature in Kelvin. What are we given? Degrees Celsius. And the formula, which will be important information, Kelvin equals degrees C plus 273. We took the time to do this, figure out what degrees C is, 21. And I can do this one in my head. And that's the answer, 294. And this one is pretty straightforward. And let me have you have some fun too. And here's one for you to have some fun. And since you may not have memorized it yet, and you don't have to, I'll help you out. Oh, one thing I forgot to mention, I write my 7 like this. I learned this from our German teacher in high school. He was from Germany. Herr Bernie, here means Mr. Great teacher. And I thought that was the coolest thing in the world. And ever since, that's how I write my 7. All right, your turn. If a gas has a temperature of 11 degrees C, then what is the temperature in Kelvin? Am I nice sharing the fun or what? Don't answer that. Well, I see somebody who's already done it. Let's find out if she's right. Give me a thumbs up when you're done. Tomorrow I'll have you do what's called a poll or vote. Remember, give me a thumbs up when you're done. I see one person, 2. The votes are coming in. Let's see another one coming in. All right, let's do this. So I have this and I'm going to read it. The gas has a temperature 11 degrees C. Then what's the temperature in Kelvin? So what are we trying to find? Kelvin. What are we given? That's the only thing we're given. And now I know to use this formula, Kelvin equals degrees C plus 273. And if I put it 11 here, and now I'll take my calculator. No, I can do this in my head. Hopefully I get it right. And this is the answer you get. That's how you do it. Oh no. I just looked at the clock. Time flies when you're having fun with chemistry and me, Dr. White. We're just about done. All right, listen up. Don't forget, the safety lab today is due Wednesday. I'm scared. Is due Thursday. The safety lab is due Thursday. Labs are easy points, so hand them in. Because if you don't, you get 0. If you hand them in and do it all right, you get 10 points per lab. And 12 of those are going to be graded. So hand in your labs. And with that, I'm done for today. Don't forget, on Monday and Wednesdays, today's Tuesday. Yeah, I put out my garbage this morning, so it must be Tuesday. But anyways, on Monday and Wednesday, I have my office hours from 6 to 7 on Zoom. And I'm done for today. Hopefully you had a good time. You learned a lot and had some fun. With that, I'll say, Gehen gesund. Remember, that means go in health in Yiddish. My grandmother used to always say that to us when we leave. Gehen gesund. And I'll say goodbye. I stole that from Granny and the Beverly Hillbillies. Bye. See you tomorrow.